Hello, everyone. Thank you very much for attending this presentation. My name is Rodrigo Linares. I'm Business Development Manager of the company New Infrared Technologies. And in these slides, I'm going to show you some infrared solutions that our company offers for quality assurance and process control in industrial applications. First, I would like to start with a general presentation of our company. So New Infrared Technologies is a company that is located in Madrid, and our aim is to develop and commercialize industrial solutions for real-time process monitoring and smart control of industrial processes. All these solutions are based in self-produced infrared cameras, which are manufactured with a unique technology that makes them sensitive in the medium wavelength infrared band with a standard response down to 1 micron. They have high-speed capabilities, and they are capable to operate in uncooled operation at room temperature. We are a vertically integrated company because we cover all the steps from the detector concept to the final product, including the detector and ROIC design, the processing of the sensing material on silicon wafers. We have a method that allows to process hundreds of sensors per manufacturing batch. We do our own packaging, etc. So in case that you need any customization, we are the right partner for it. Our cameras and solutions are targeted to integrators, solution developers, and end users that are requiring monitoring and control of industrial processes. Some of the solutions and systems that we offer are listed in here. One of them is Clamir. Clamir is a real-time closed-loop system for the control of the laser power during laser DED processes. This is a metal 3D printing process. We also have i3MS. i3MS is a process for quality monitoring of the industrial. It's a system for the quality monitoring of the industrial process. And we also have a camera called Tycoon 16K Camera Plus. This is an uncooled high-speed mid-IR camera, which is capable to acquire up to 4,000 images per second with a snapshot acquisition, and the camera has also industrial machine vision interface. These are the solutions that I will present today in the next slides. I would like to start with Clamir. Clamir is an embedded system which includes the infrared camera, the image processing electronics to extract dimensional features of a melt pool, and electronics for controlling the laser power. This is a system that performs a continuous monitoring of the measurement of the melt pool geometry, and it's oriented for laser DED process control. This is a metal 3D printing system. The camera is capable to perform a closed-loop control of the laser power during the complete process, and this ensures the quality and repeatability of it. It's compatible with most of the laser optics and powders. The mechanical integration is very easy. It's capable to be configured really quickly and allows retrofitting. The main applications or the main processes where this Clamir system has application are LMD, laser metal deposition, laser cladding, including the high-speed laser cladding ELA for depositing metal coatings on surfaces. Here you can see a couple of examples of what Clamir is, the benefits of introducing Clamir in the production line. The first one you can see in the upper image, a massive cubic structure in which the control has been performed, and we can see that the growing of the part is consistent. On the other hand, on the lower part, we can see two metal tubes. The one on the left has been performed with control. This is you can see that the walls are very consistent and homogeneous. Whereas on the right side, we can see a cube that has been performed without control, and meaning that the process was had to stop because there was an overheating affecting the upper layers of the part. And in this case, this can cause a stop of the machine and stopping the process, having a great impact on the productivity. The screen and the software screen shows the operation of Clamir. You can see how the system is monitoring the melt pool, showing the width, the instantaneous width of the melt pool in the red line, whereas it's controlling the laser power, and that's the blue line. You can see that the control is continuous. Here we can see another example of the Clamir operation. This is the manufacturing of a triangular shaped part without control on the left and with control. In the left part, we will be able to see how the heat is transmitted to the upper layers, and this can cause that the walls are not homogeneous and the quality of the part is not correct. Whereas on the right side, we can see how the part is grown consistently, and we don't see we see that the walls are more homogeneous and more flat. Okay. Another one of the systems that I want to present is I3MS. I3MS stands for Inline Infrared Imaging Monitoring System. This is a camera that is installed on looking at the process and performs a continuous monitoring and measuring of the melt pool and heat affected zone geometry. This system generates an analog output proportional to the width of the melt pool, which can be used for quality assessment. And in addition, the system allows to configure two alarm levels in case that the melt pool width deviates from the thresholds established by the customer, by the user. The main processes of application for I3MS are in the 3D printing process field, laser DED with powder or wire, WAM, or in laser welding. To finish, I would like to show the information about the high-speed camera for industrial process monitoring called Tycoon 16K Plus. This is currently our state-of-the-art of our technology. This camera has a resolution of 128 by 128 pixels. It's operating in cool mode, and the maximum frame rate that it can acquire is 4,000 frames per second. But making a windowing of the acquisition area allows faster frame rates. The camera has industrial machine vision interfaces such as Gigi Vision, and is compliant with the GENICAM protocol, and it's also powered over the Ethernet. On the right side, we can see a video of a melt pool in a powder bed fusion process. This is also a metal 3D printing process in which we could extract features such as the length, the width, the maximum intensity, and the angle of the melt pool. This information could be used also to calculate the cooling rate, for example, based in the infrared image. And in the bottom part, you can see the camera coaxially integrated in a powder bed fusion machine, in which we could acquire the data that is shown in the upper video. Well, with this, I finished my presentation and showing the systems that could be interesting for you for industrial process monitoring. In case that you want to have more information, you can visit our booth at Photonics Plus, following the link shown in the screen, or you can contact us at sales@niteurope.com. Thank you. In case that there is any question, I will be happy to answer it. Okay, I can see that there is a question about the communication interface. In most of our systems, they have gigabit Ethernet connection and USB. But these are systems oriented to low power consumption, so in principle they could be used as sensors installed in the production line and providing data continuously as an Internet of Things device.